Today we're going to talk about the distributive property. Now it's something we actually already talked about earlier this year, so let's start with a quick review of what we know. The distributive property is when you want to multiply a single term by something with more than one term, or what we'll call a polynomial. Now we just finished talking a lot about multiplying terms. Now instead of multiplying one term by one term, we're going to be multiplying one term by something with more than one. So in the problem, it's probably going to be shown as one thing in parentheses that has more than one term in it. That's our polynomial. And then usually out in front of it is just a single term all by itself. Now a simple example of that could look like this. You have 3 times, and then in parentheses 2x plus 5. And you would distribute the 3, and that's what we did. I told you we've already done this year. Now what we're going to change is we're going to make the terms a little bit more complicated, like the ones we worked with yesterday. So basically, instead of just having that nice simple 3 out front, we might have a 10x squared y to the 5th, or something like that. But it's still the same rules. In order to multiply a single term by a polynomial, we're going to multiply it separately to each term of the polynomial. And we usually call it distributing, because it's the distributive property. Now what's different is, in that example I gave you earlier, it's 3 times 2x, that's simple, it's 6x. Now all of a sudden the multiplication part might be a little bit trickier. Our outside term might say 10x squared y to the 5th, and we're multiplying by 15x to the 10th y to the 7th, or something like that. So just remember the rules from yesterday for multiplying terms. You multiply the number part first, the coefficient, then you go through each variable one at a time and you multiply them by adding the exponents. So let's try one out. Here we have a distributive property question, and you can tell that you're supposed to use the distributive property here because of how I explained it to you before. You have a single term out front, that's 2xy squared, times, and then you have something, there's actually 3 terms inside the parentheses. So remember when we were talking about terms, we said every time you see a plus or a minus, every time you see addition or subtraction, that's changing from one term to the next. That's how I know that inside the parentheses I have 1, 2, 3 terms. So what I'm going to do is I am going to distribute, or take this term and multiply it times each of those 3. So let's do the work, let's write it out and show what we have, and then we'll finish our question. So what I like to do, and most people do this, to show work for distributive property is we use these little arrows. So I do this little arrow here. Now what that arrow means is I'm taking the 2xy squared and I am multiplying it times the x squared. Okay, now after that, basically the plus or minus just gets copied down. So this plus just gets copied down right here. Okay. Then we'll distribute the 2xy squared to the 3y. And it's just multiplying again. 2xy squared times 3y. Okay, then that minus gets copied down right here. And we'll finish it out by distributing the 2xy squared to the 5xy. So we will have 2xy squared times 5xy. Now each one of those, red, then purple, then light blue, becomes a problem just like we did last section. It's multiplying terms. So let's do each one. I'm going to do this multiplication part first. Now I have some hidden ones here. We talked about when you're multiplying terms, you have some hidden ones. That x that we have all by itself is actually x to the first power. And that x squared that we're multiplying by is actually 1x squared. So you can put those ones in if you want to. You don't really have to, but you can. And then what we do is one at a time. I do the number part first. 2 times 1 is 2. Then I do the x's part. And I go x to the first times x squared. I add those exponents. 1 plus 2 is 3. And then I have a y squared times nothing. So I just leave that y squared in my answer. So the first part of the question is done. I'm going to put the plus in next, and now we'll do the purple one. Now I have the same hidden one as before. Remember, this x is an x to the first power. And let's just do those same 3 steps. Do the number part first. 2 times 3 is 6. Do the x's second. I have x to the first times nothing, which is x to the first. Now I'm just going to put x. If you want to put the 1 there, that's fine. There's nothing wrong with it, but you don't really need it there. And then, oh, you know what? I actually did have one more hidden 1 here. That y is y to the first power. So now when I multiply the y's, I have y squared times y to the first, and 2 plus 1 is 3. And then I'll put the minus in, and we'll finish up 1 step left. We'll do the light blues. So 2 times 5 is 10. I have 3 hidden 1s actually. X to the first, y to the first. So let's not forget any of those. X to the first times x to the first gives me x squared. 1 plus 1 is 2. And then for the y's, we have y squared times y to the first. 2 plus 1 is 3. And that right there is my final answer. So I color-coded it to make it stand out. We kind of did 3 separate problems here. The arrows up top show you the distributive property. Each arrow represents a multiplication problem. Each multiplication problem is what we just finished doing in the last section. So in red, we have 1 multiplication. In purple, we have another. In light blue, we have the last one. And they are separated by those same pluses and minuses from the original polynomial. And that's our final answer. All right, so that's distributive property. We already learned distributive property earlier this year, but that's distributive property applied to a little bit more complex terms like we've been working with. And that's our focus for today.